In your opinion, which of these technical breakthroughs will profoundly impact industries beyond the tech sector?
I think audio is the thing that people will do. I think it's clear that, I'm like the classic example of people that likes to consume a lot of media, but does so through audio. If AI is as powerful as people think it could be, it could result in companies that are 10 times as big as Apple and Microsoft. And then we don't really know how the modern economic system would work in that context. It's just having a lot of people being able to work in AI, having AI be understood because it's going to be very powerful over these next few decades, making sure there's not risks through obscurity and people not knowing what's going on, but then also just like education and more people getting involved and these very long-term kind of societal shifts.
Nathan, welcome to the Super Data Science Podcast. I'm excited to have you here. Where in the world are you calling in from?
I'm in Oakland, California for a few more weeks. Thanks for having me, John.
Nice, my pleasure. So let's dig right into the technical stuff here. So you're currently a research scientist for the nonprofit Allen Institute for AI, where you work on reinforcement learning for human feedback, RLHF, and fine-tuning LLMs in the open and for the common good. Earlier this year, you released the LLM Olmo, and Olmo has been praised for its openness, including providing pre-training data and training code. So people are probably aware that for the most part, when there's supposedly open source models like the Llama series or Gemma, they're not open like yours is.
Yeah, companies are getting better at talking about it. They release internal documents telling people how to communicate about it, but some people mess it up still.
Yeah. Well, we really appreciate all the openness. What do you think are what are the reasons driving you behind having as much openness as possible with these AI development tools that you create?
It's like various. It's wanting to have quote unquote a good outcome, which is very biased by what I think of as good. But it's just having a lot of people being able to work in AI, having AI be understood because it's going to be very powerful over these next few decades, and just like making sure. And then the worry of probably largest corporate capture, where if we have if AI is as powerful as people think it could be, it could result in companies that are 10 times as big as Apple and Microsoft. And then we don't really know how the modern economic system would work in that context. So just kind of spreading the love, making sure there's not risks through obscurity and people not knowing what's going on, but then also just like education and more people getting involved and these very long-term kind of societal shifts.
Yeah, on that note of things happening at the big tech companies, in your interconnects.ai newsletter, you recently published an article about OpenAI's model spec. So this document details how they steer their model with RLHF toward their goal model behaviors. And can you elaborate on, I guess, RLHF a bit in general for our listeners that maybe don't know it? And what your findings were about this kind of model spec document.
Yeah, so RLHF, this reinforcement learning from human feedback, is the most popular fine-tuning technique right now. It's interesting to people deep in the weeds of language models because it's a different loss function. I think all this pre-training is done, and when you hear about instruction fine-tuning or supervised fine-tuning, that's with the same autoregressive loss function that's kind of at the core of modern NLP. And it wasn't always the core of NLP, which is fun to learn about. But this RLHF process kind of brings in this human factor. So it lets the models kind of have some humanness that is hard to capture in data. And then it's like a really broad loss function. So there's a lot of different things you could try. Like we're just still barely starting at understanding, like now that we could do policy gradient updates or different types of updates to these models, like how different can we make them in very useful ways? And that's a tool. So RLHF is a tool for doing this. It seems very likely to stick around. If you had me on a year ago, I would be like, oh, I don't know. We're going to try. But at this point, everyone's investing in it. Scale AI did a Series F round on tons of revenue. Like that's built on RLHF. They've pivoted their company for a second time. And this model spec thing is like a nascent corporate direction thing, which I think a lot more companies will do. OpenAI again is at the forefront of this. It seems like it's a combo work from John Schulman, who's like this author of this proximal policy optimization paper and one of the the leading authors of DeepRL as a field before language models come in, and then also their product team. And it's essentially trying to say like what we want our language models to do, whether or not we get the technical details right. And then they're going to update this document over time as they kind of like better understand their customers and their company culture. And as a standalone document, it's interesting to people very in the weeds like me. Like, what are the examples they give? What is the commentary they give? Like, they talk about NSFW content and like how it's hard to thread that needle, and like the order of command. So like OpenAI has final say on what the model can do relative to the customer and all these things. And just having it in one place is good because eventually we're going to have multiple model providers do stuff like this. And then if you're shopping around, you could see like, oh, what does Google want their models to do, or Anthropic, OpenAI. And it's even something that we want to try to do at the Allen Institute, just to be like, what are we trying to do? Like, we're pretty behind on terms of what the RLHF practices are. Like, we don't have as big of a budget for human data, but we want to be able to say like, these are our goals and we're going to see if we can achieve them. And then we can document how our goals change over time. And it's just kind of a nice feedback loop to be like, RLHF is a messy process, but these are the sort of things that seem tractable to do with it, whether or not it actually works.
Yeah, yeah. And so while at AI2, which is the abbreviation for the Allen Institute for AI, yeah, so while you may be working at those details around RLHF still, you've published a popular paper called Zephyr, Direct Distillation of Language Model Alignment, about how you leveraged distilled direct preference optimization, so DDPO, for intent alignment in smaller models, which allows this 7 billion parameter Zephyr model to surpass the Llama 2 70 billion one, so 10 times as many parameters. How does this approach differ from traditional methods, and what are the implications for scalability, transparency, accessibility?
Yeah, so this Zephyr paper is mostly about the like direct preference optimization DPO paper, kind of making it mainstream. It's funny, just 2 days ago, yeah, Chris Manning had me for a lecture in his class, and he's like, "Oh my god, thank you guys for making DPO seem real." And it's like because there was this big time lag. The DPO paper came out in about June of 2023, and then the Zephyr model was released in September of 2023 as the first real model to make a breakthrough with this DPO method, which is a long time when there's so many labs invested in training these models and releasing them for like PR and product gain. So it's like there's a huge time lag there, and it really built on just strange exploration in terms of experimental details. Like, we need a really low learning rate. There's the meme in AI that 3E minus 4 is the only learning rate that you need, and it works for everything. But this model and the model later at AI2, which was the Tulu 2 model, which was 70 billion parameters, showing it could scale, like both used like a 5E minus 7 learning rate, which is just so outside the realm of normal for most people doing fine tuning and anything with AI at the time. And then there's also this idea of synthetic data, which is this like direct distillation idea. So there was a data set called Ultra Feedback from a group that's like OpenBMB, which I think is a research group based in China. And that data set, and still to this day, if you compare to other preference data sets like Stack Exchange or Stanford Human Preferences or like Anthropic's HHRLHF data set, it's just using the methods that we have on this ultra feedback data, which is a mix of completions from models like GPT-4, GPT 3.5, Llama 2, and then the like chosen and rejected completions for creating quote unquote preferences are labeled by GPT-4. So like this data set is 6 months on from Zephyr and Tulu is still what we're seeing as the best. Like by the time this is aired, we'll release some more models trained with PPO or soon after this airs. And we're still like the best results still come from using this data set. So as this conversation goes on, I'll probably like keep beating my drum, which is like we need to get people making more data sets in the open if we want to keep doing this academically and for open source. But I do that in a lot of channels. But it's obvious if the field will move so much. Like we have these Llama 3 models. I'm sure Mistral will come out with something soon, but we're still using the same one data set. And like it was like the first one of its class too. It's like people don't get the first one perfect, especially when it's a research lab, but it's impressive the longevity of it.
Yeah, in addition to Zephyr, while at AI2, you also released Tulu 2, if I'm pronouncing that correctly. There's like an umlaut over the first U.
Yeah, it's a hybrid camel. It's what a Tulu is. It took me so long to learn this. There's two types of camels, and the Tulu is what happens if you crossbreed them. I didn't come up with the name, but that's what it's named after.
So like they're the mule equivalent for camels.
I think so.
Well, so regardless of the etymology of the term, Tulu 2 is a suite of models for adapting pre-trained language models to downstream tasks and user preferences. how does Tulu adapt where other instruction tuning models and methods fail?
Yeah, so this is really the bulk of this project was about understanding the most important instruction data out there. And then like we saw Zephyr come out. So we're like, let's apply the Zephyr method on top of it. And like the Zephyr method again worked on these models. So it's kind of like a proof of concept that this ultra feedback data works and at different scales. So it's really the 7 dB scale, which again was like to counter the DPO haters, which is like everyone's like, oh, DPO works at 7B. Like no one's going to really use this if it doesn't scale up. And it was like a month later, we're like, oh, look, we did it. And it was just kind of funny. But there's a lot of instruction data sets out there. And this becomes very messy. I think if you're deep in the weeds of instruction tuning, you also see these people that are like independent affiliations that are trading all these models and uploading them to Hugging Face. And they're like, we have a million examples in our data set from like this list of 15 different places, plus some weird filtering heuristics. And Tulu is like the academic version of that, which is focusing on very specific evaluation metrics, trying to understand like particularly some things in like code and reasoning that are harder to improve with the current models, and doing a rigorous study on like how you can it's kind of a two-stage thing that's wrapped into one result, which is how you can improve these with all the data that we have. And then you have a giant data set, and then how do you prune it down to maintain the maximum performance? And what this looks like in terms of Tulu is grad students running a ton of experiments and just like getting really deep into the weeds. And there isn't a systematic answer. It's like the next thing is to do automated filtering. So like the grad students take away from this project and they're like, we can't do this by hand anymore. And they're like looking into ways of doing automatic filtering based on like embeddings, or they're looking at influence functions, which I don't even know what they technically are. But it's like a measure of similarity between instructions, and trying to use this to kind of automate the process of filtering through the vast amounts of instruction data online.
Nice. Yeah, really cool. All the things you're doing at AI2. It must be an incredible place to work. And it sounds like you moving there is to take even better advantage of that, moving out to Seattle.
Yeah, it's good. It's like one of the last holdouts of academia and industry hybrid. It's like every workplace, I know everyone has a job. Like there's always upsides and downsides, but it's like a very unique place as industry research has become more closed. But we don't have the resources of industry research, so we have to be a bit more clever in terms of how we do things.
Are you stuck between optimizing latency and lowering your inference costs as you build your generative AI applications? Find out why more ML developers are moving toward AWS Trainium and Inferentia to build and serve their large language models. You can save up to 50% on training costs with AWS Trainium chips and up to 40% on inference costs with AWS Inferentia chips. Trainium and Inferentia will help you achieve higher performance, lower costs, and be more sustainable. Check out the links in the show notes to learn more. All right, now back to our show. So prior to AI2, quite a bit because you were also at Hugging Face. But prior to that, you were at UC Berkeley and you focused on the intersection of robotics and machine learning, which for me is personally super fascinating right now. So there have been some really exciting developments in that space recently, things like NVIDIA's Project Groot for humanoid robots using generative AI and reinforcement learning. And there's also the announcement of an MIT spin-off Liquid AI, which plans to revolutionize robotics with liquid neural networks.
Oh, I didn't even know they're a robotics company. I saw them, but I didn't know.
But so what's exciting for you at this intersection of LLMs and robotics? What's promising there for us?
Yeah, I think the place all of this really started was Google Brain's research team on robotics. They're still doing great things, but they were years ahead to embrace this, which is like, let's scale up our data engine, let's train some big models. And then it kind of just worked. That'll clearly continue, and on more and more complex tasks as people invest resources in this data. There's kind of a product market fit issue, which is like, I don't want to buy a robot. So like most of the really nuanced takes come on this product side. I'm pretty confident that the research is going to keep going places. I think this is the kind of the two biggest trends in robotics and machine learning in the last few years in my mind. One of them is this kind of scaling up data collection using some sort of large model. You can get real world results that work. Google showed this. Other places have replicated it. They did this like open data set project. But there's also like DeepRL's like actual success area has narrowed and narrowed down to this kind of like simulation for robotics, where you have like procedurally generated worlds and you simulate for robotics. I feel like I should try to do another survey on this, but I wrote a blog post like a year ago that was just listing a whole bunch of places where that has worked. It's like drone flight, locomotion, other things like DeepMind had the nuclear fusion paper. And it's like there's all these really wild things that are really narrow scoped DeepRL is helping with. So I think that's what most robotics companies will be leveraging is like we have our robot farm internally that can collect data. And then it's a question of how do you integrate like consumer data, or if you're trying to like humanoids are hard because at a mechanical level, most of the humanoid robots have such high force that it's hard to have them around humans. I think this is what was maybe like used to be like wherever Eric Jang works, like 10x robotics or 1x robotics. They're trying to make actuators that are lower force, so it's safer to have them around humans. I think like famously the Boston Dynamics robot, like you can't have humans around it because if its arm is doing a motion and it hits you, you go flying across the room because there's so much force. It's like that's not safe. So then there's this kind of weird last mile consideration, and then but I which had me really down on it. And then I was talking to the family friend, and he's like, but teleoperation can save you. So it's like if you want to have humans in your house and or like robots in your house of any type, it's obvious that they're not going to work for many things, but you could outsource the labor to like India, and there will be people that'll happily like empty your dishwasher manually instead of the robot failing to do it automatically, which like creates a whole like a redistribution of labor market, which like arbitrages costs and stuff, which I actually think would probably work if people got over the privacy concerns. So I kind of skip something in the middle, which is like having robots in your house is probably not going to work for a really long time because of the distribution shift. But I think most people that are serious about that. And then it's like if the distribution shift is such a big problem, that's when you do the teleoperation. I respect a lot of people that are joining this field right now because there's a lot of opportunity to grab in the language model space in terms of digital applications and building services. It's like the people that are still doing their fundamental research, or the people that go to robotics. It's like y'all are taking the long term thing. I think Eric Jang specifically was like, yeah, this is like a 10 to 20-year bet for humanoid robotics. And I was like, respect for like taking the big risk, because it does seem to be going in the right direction. And robotics has been, if you take away like the Stable Diffusion moment and the ChatGPT moment, like the robotics trend line is just like the same. It's just like slowly going up, and we're pulling in new things. So it doesn't have as much of a splash factor. The splash is from people like Elon marketing it now. Like Tesla Optimus is probably going to be similar to Autopilot. It's like I don't really think of it as exactly what it's marketed as, but they have a really good team there and they're building a cool robot. And then that mismatch will be managed in some downstream way.
Nice, gotcha. So basically, you think that it's going to be some time before we have humanoid robots in our homes doing a lot of regular tasks. So where we're going to see more and more robotics applications are in industry typically.
Yeah, so like there's three really popular Bay Area like robotics and AI startups, which are like Dexterity, AMB, and Covariant, and all of them have contracts with companies for various logistics tasks, like pick and place or unloading a truck or loading a pallet, and they all work really well on this. Amazon does this. Like Amazon is setting up their fulfillment centers to be robot first. They build entire fulfillment centers from the ground up to be ready for robots, then rather than being ready for humans, rather than subbing robots in for where there were humans. So all of this really works. It's like, how do you get them to leave the like manufacturing line type of thing, which is just so different.
Yeah. And so related potentially because of how we're now seeing LLMs more frequently in robotics applications, like the Groot explanation from earlier. And you just mentioned Covariant. They had a really cool one too. Their Robotic Foundation Model 1, RFM1.
Like that stuff is the way to get to human interaction. Like having language with your robot is the way. It's just going to take a lot of reliability for somebody to want to buy it.
Yeah,
it seems so logical.
Yeah, it's cool for sure. And so related to LLMs, in your newsletter, you recently wrote an article about GPT-4o that features significant improvements such as latency and real-time audio generation. In your opinion, which of these technical breakthroughs will profoundly impact industries like, beyond the tech sector? So healthcare, education, finance, perhaps making it even into robotics.
What are the two? I think audio is the thing that people will do. I think it's clear that, I mean, I'm like the classic example of people that likes to consume a lot of media, but does so about through audio. And we've seen this, and it's like people watch so much YouTube and so much TV and so much TikTok, and it's like how many people watch TikTok versus read Substack newsletters? It's so low, but that removes a barrier to entry in terms of actually using these language models. And like GPT-5o, when it exists, it's like it's probably going to be so good in every language. Like you could just put this in front of a kid that doesn't speak any English, and then he has a perfect tutor for anything, even though most of the education material is in English. It's just ChatGPT has already learned all of that, and it just exists. And it's like the downstream accessibility to education is just so high. I think there's like obviously social concerns, but it's also starting younger. Like they don't need to be able to write coherent questions. Like there's protections you need to add if kids are going to be using this, but I, I think you could come up with an infinite list, a growing thing of just how talking to these machines with no latency, especially when kids are so clever. Like my parents would probably be more thrown off or take longer to adapt to like an AI that they can interrupt, but like a kid probably figures it out in 60 seconds and then they're just going. And they're not even probably going to talk to it like a normal human. They're probably just going to extract the information from it in some like unparsable, weird way.
Yeah. I think you're right. It's like I can't really figure out TikTok still.
I just protect myself. I'm too deep in the tech industry to know. It's like all the tech kids are like protected from all these apps. It's such a sham.
So going back to RLHF, which has been a huge focus of yours, not only at the Allen Institute, but also at Hugging Face, where you were previously. In your paper, The Alignment Ceiling, you discuss the issue of objective mismatch in RLHF. So, what are the challenges in aligning reward models with human preferences in a reproducible manner?
Yeah, so this paper is kind of a fun story because it harkens back to my PhD. So the PhD work on model-based RL, like the objective mismatch paper, was kind of my like core paper of my thesis, which is that in model-based RL, you're learning a policy in a dynamics model. So it's a bit simpler because the evaluation regime is much more closed. So like in classic RL, you have these like robot tasks and simulation. So the evaluation is much more set. And then you can kind of think of it as like the dynamics model that is good for the policy is tuned to the policy. It's not tuned to the real world. In RLHF, it's a bit different because you're kind of trying to do like a multi-stage process where you have like this language model, which is your policy. You have this reward model, which is like sort of like your environment, but it's mirroring to what the humans want. So there's this extra leg of trying to like match what the humans want, and then you have this reward model, and then you have the policy that's trying to extract information out of it. There's a lot of analogies. I've been recently talking about like information flow, which is like if you have this policy that's getting trained, the reward model is some sort of filter or sieve or like gain. You can think of it as many different ways. And you need to tune that. There's like you're putting information through a black box, and you need to tune it to make sure that it matches what humans actually want. I think this is part of why the model spec is interesting. So doubling down on what the model spec partially reveals is that when these big companies are collecting preference data from humans, they have like 10 to 20 page documents on here's what you should prioritize when you're labeling the data. And the model, and then the question that we haven't been able to see of these models is what is the mismatch between what they tell you to do in the data and what the final model does? So if you tell them in the data, like prioritize factuality, prioritize conciseness, like even if the data has that, does the training process result in a model that does this? And that's kind of like the best representation of what we're saying is like this alignment ceiling is like, we don't know if our methods ever could actually be perfectly aligned with what our expectations are because we're doing this all in different modules. And then the really deep, this is less in vogue right now, but in deep RL days, people would be like, can't we just do end-to-end learning? So if we only have one objective, can it learn everything at once? And that just doesn't seem to scale as well in like realistic engineering environments. I think the only people that we see doing that is like Tesla self-driving. And we don't know for sure if they are, but all of the teams at OpenAI, Gemini, Anthropic, they have modules where it's like an RLHF team, a safety team, a pre-training team. And like that is where they trade off these things. And that's like, if you look at this paper, that's what each of those boundaries are, where you're trying to design your optimization in the context of the optimization that other people are doing. So it's kind of, it's just this mathematical thing where it's like you can never get a perfect solution if you're doing multiple optimization problems.
A big alternative to RLHF is constitutional AI, or reinforcement learning from AI feedback. You've discussed that in other places, papers, talks. Can you elaborate on this idea? I know Anthropic is a big proponent of it, for example, because it seems like some people might be concerned that if you're using AI to judge AI, that, where's like the real ground truth,
Yeah, so I think constitutional AI is one of the most misunderstood techniques, and this is mostly because the paper is somewhat confusing. So there's two things. There's two major things in this paper. You'll see constitutional AI and RLAIF. And RLAIF is the idea of using AIs instead of humans to label preferences, which is pretty general. And constitutional AI is a two-stage process, which does some RLAIF and like some other instruction revision stuff, where what they do in this paper is they revise the instructions in their instruction data set with respect. So like the completions, they revise those with respect to a list of principles. That's one thing. And then they redo instruction fine-tuning. And then the other thing is they redo this preference label with the context of a principle. So that's what people normally think about. And it's just one more way of kind of adding synthetic data. And I think that they've likely moved well beyond that at this point. The paper's pretty old. Some other sorts of things that you could do in this case is like you can do a revision to create a preference data. So if you have a bunch of completions from a language model, you could ask it like, is this factually correct? And if it says no, you say, can you fix it? And if it fixes it, then you have a pairwise preference where the chosen preference is the fixed text and the rejected is the original one that needed to be fixed. And this is like one of a growing list of examples of ways that you can generate kind of synthetic data, of which CAI is the one that Anthropic got a lot of buzz on. It's like a buzzy name. It was by far and away the earliest. And it's just like it's so misunderstood. I mean, I don't feel like I really understood it until a couple months ago. It's just like one of those papers that ends up meaning something that different than it actually is, which is fine. It happens.
Nice. All right. So back to RLHF. Given the inherent subjectivity in human preferences, how do you ensure that the aggregated preferences accurately reflect the desired outcomes for our AI system's behavior?
Yeah, we've been debating this a lot internally recently. It's essentially, you could phrase it as, is the disagreement among labelers a signal or a bug? And it honestly feels more to me that it is kind of a signal because of how vague and multifaceted these preferences are. It's like we don't know what everyone's doing. There's research on this kind of fine-tuned RLHF where you label multiple pieces of an answer. But at the end of the day, a lot of it's being reduced to a pair. And we have different weights for how much we notice different things like factuality, conciseness, helpfulness, honesty, like these very kind of abstract terms. So if this gets reduced, there's going to be some noise. And that's seen in the papers where they all report these like agreement numbers with their annotators, and it's somewhere between like 65 and 75% agreement when the people doing research compare their numbers to the annotators. I don't think that's going away. People see that when they use a language model, it has higher agreement. I don't have a strong opinion on what that means. It could be one of those things where it's like you're amplifying biases when you keep training on with language models. Is they have less disagreements, they have more agreement. And what that manifests as is like the diversity of answers maybe going down in terms of what's acceptable. We really don't know. This is where I said I was going to beat this drum. This is why it's like we need more clearly like labeled and this within good metadata, open preference data sets, so we can kind of see. Something that I'm encouraging a lot of people to do now is that we have 3 really good language models. If you're going to do GPT-4 as a judge to label a data set, like do it with all 3 of them. Do it with Claude, do it with Gemini as well. And then we can kind of see like what the disagreement between the language models is. And we get that at scale. We start to learn a lot more.
Today's podcast episode is brought to you by Crawlbase, the ultimate data crawling and scraping platform tailored for data scientists, AI developers, and Python developers. For ML and AI, high-quality data are, of course, essential. With Crawlbase, you get a powerful, user-friendly solution that guarantees seamless integration, lightning-fast performance, and unparalleled reliability. Crawlbase supports your needs with a 2-minute integration process, AI-powered efficiency, and 99.99% uptime. Crawlbase also excels in bypassing CAPTCHAs, avoiding IP blocks, and handling proxy failures, making them the go-to solution for all your data needs. Use the special code SUPERDATASCIENCE, with no spaces, to unlock 10,000 free requests. Visit Crawlbase today and supercharge your data collection process with the best in the business. Nice. Very cool. Another really cool thing you've done related to RLHF is you have traced it back to ancient philosophy and modern economics. So mentioning Aristotle and the Van Neumann, Morgenstern utility theorem, for example. I don't really know what the VNM utility theorem is, but how do these historical foundations influence current methodologies? And what can modern AI research learn from these early theories?
Yeah, so this is a fun paper with a few colleagues that I started working with at Berkeley, and now we're kind of spread out. This is all based on the fact that like RL is very deep multi-field kind of multidisciplinary history, whereas like it goes way back. And then the notion of preference is a very vague thing in economics, and it's like the von Neumann Morgenstern theory is a foundational thing that essentially it's like you can express either all behaviors or all goals as probability and expected value distributions, which essentially lets you do like expected value math over preferences. And then it led to a bunch of debates on whether or not preferences like actually exist and are tractable in any of these things, or if they're actually measurable or not due to the preference shift over time based on context. So these are the kind of things that we take, and it's like ask a lot of questions on how this impacts the modern RLHF process. It's things like, is the final model's preferences, which are like we're mapping onto very human terms, is that actually based more on the preference model, the base model, which is scraped from the internet, than the like human preferences that they get from somewhere like Scale AI. So it's like if it's based more on the internet crawling than this $1 million data set they're getting from Scale AI, it's like kind of confusing to the marketing, or we're saying we're learning a preference model, but it might not actually do that much. There's other things like OpenAI now has a ton of user data, and it's like, what does the economics literature say about generating data for training that comes from a user context or a professional context where someone is paid to do it and they're paid to act in a certain way? And how does all of this mix? So it's really just like a super long list of questions of like why we should look at other social sciences if we're making grand claims about human preferences and all of these things.
Nice. Well, fascinating. Tons to dig into there for our listeners. Final kind of topic that I planned related to RLHF, I'm sure it'll come up again, kind of organically in the conversation. But you've mentioned that RLHF is not even robust to fine-tuning. And so removing the safety layer from models like GPT-4 and Llama 2 can break down the notion of safety. Can you elaborate on the implications of this fragility for the future development and deployment of AI systems?
Yeah, so this is like a specific line of research. There's a few papers that showed that if you take a model like Zephyr or Tulu that we were mentioning, if they have like safety in the data set, if you then go and fine tune it again on some different task, you'll lose some of the behaviors that are quote unquote ingrained in the model. I honestly think this is a little bit more like clickbaity than like actually worrisome, because it's really not surprising given that like if you just look at the amount of compute applied at fine tuning, like we pre-train these models for trillions of tokens and then we apply like a couple billion tokens of compute at fine tuning, and it's like we're not changing the weights of the model substantially. Like we're doing a slight nudge, and it makes sense that a slight nudge could be undone at the same way. But if you to take this to some of the bigger labs, what you hear is that like safety is not just like a single artifact thing. Like safety is much more about a complete system than a model. So like open weight models being unsafe or unsafe, I don't consider to be that big of a deal. It's like if you were to apply them to a free endpoint that everyone on the internet could talk to, then I don't want my model saying good things about Hitler and like all these obvious things. But if it's like a research artifact that you like need to spin up GPUs to use yourself, and it's like a little bit more, I'm more open to having these diversity of models exist. But if you ask Anthropic or somebody, it's like, what happens if, like, how do you get safety into your model? And it's like, it's not just RLHF. Like, you need to have safety at the pre-training, any preference model you train, and then all of these models have a safety filter on the output. So like the ChatGPT, it reads all the text generated from the base model, and then there's like a go no go where it will rephrase the text if it gets a no go signal, which is like their content moderation API. So it's like, it's kind of a double, like it's like it's the type of thing when researchers need to market their work, but it's not as big of a deal as I think it is. It's like, okay, I think it has interesting business downstream things with liability. So it's just like, if you want to fine tune a llama model, you normally do that on your own hardware. But OpenAI has a fine tuning API, and if they like claim their model is safe, but any fine tuning on their API that they then host makes it unsafe, like that seems like more of a business problem. Which is like, oh, it's a nice way that open ecosystem might be better off because it kind of breaks the liability chain. But we'll see this research continue to evolve. It's like, it's so early at all of these things. We're like a year in.
Yeah, that is something that I had not thought of, is how if you're fine tuning the OpenAI model via their API, you are potentially removing some of the safety stuff, which hadn't occurred to me. So moving on from RLHF into some other topics. In your podcast, The Retort, you've discussed AI being closer to alchemy than science. Could you elaborate on this perspective and its implications for how we understand and develop AI tech?
Yeah, I think a lot of this is about the culture of AI, which it really does when you're on the ground feel like things will just work. And we don't, there's a lot of people that it's like you're operating at a scale where real hypothesis testing doesn't really work. It's like, what are you, like, we do like 10 experiments at the 7B scale, and then they're like, we're going to train a 35B parameter model based on some like reading the tea leaves and intuitions of what we have seen, because we don't have the infrastructure to do thorough testing, which is like proper randomization and like really thorough little things. So it's like definitionally not that scientific. And there's a lot of people that in the field where it's just not. It's like science is a very clear process that people are taught. And it's a lot of just like, oh, we're going to try this because it feels right and it probably works. And then there's the whole culture thing of like how these companies cast narratives about their things being like pseudo religious artifacts and all the AGI talk and stuff, which makes it unscientific in many ways. I think it's a lot more of my co-host Tom's favorite thing to talk about, but I understand the argument and I agree that it's apt. It's been like this for a long time, where it's like deep learning being uninterpretable fundamentally makes it kind of hard to do science.
Totally, yeah. It is wild, and it's crazy to me how when you say, okay, with GPT-4, we're going to have 10 times as many parameters as GPT-3, GPT-5 will probably be that same kind of change. Even the people themselves who are developing these systems don't know what emergent capabilities they'll have. So I think that kind of relates to this idea
Yeah,
of it being an alchemy.
there was this NeurIPS best paper I last year by Ryland Schaefer, who gives fun talks. He's really good at storytelling for his papers. But the best paper essentially said that the emergent properties, a lot of the measurement is through like statistical measurement error, which is like we have all these benchmarks where the random floor is 25%. So then like weird statistical things emerge when you finally get signal. So if you're like training these things, what the training of like what the test set loss would look like is probably like a line going up on log compute versus like as you get x-axis is log compute and the y is like performance going up linearly or something like this. But if you have a noise floor at 25%, like, or something weird where it's not having any signal and then it kicks in, it looks like instead of being a straight line, it looks like a flat that then goes up. So that's the whole idea of the paper, is that most of these arguments are measurement noise. I think it's probably somewhere between that and reality, which is like we are discovering things that are unpredictable with the largest models, but the way that we're presenting them flatters this emergent hypothesis just because of the way that benchmarks were created. So I think that was interesting. It's one of those papers that really should be like a blog post because the idea is so clear, but like we have to go through the academic gating cycle, so it ended up being a paper. It's just pretty funny.
Another topic that you covered in your podcast recently was you discussed the idea that RLHF could be fixing something in the pre-training and that it might be correcting biases from common data sources like Reddit. Yeah, so what's the problem there with using those kinds of common data sources like Reddit? And how is RLHF addressing those biases and implications?
It's kind of two things here. I've been parroting this theory that fine tuning is important, even if it's not as much like raw compute because of how you present information being so important. I like to use this analogy of like the Sapiens book, which is obviously stuff that's in history class, but he rewrote it in a way that was so compelling that is like one of the most selling books of all time. And RLHF is doing that at a small scale, which is like all these base models have similar things in them, but the models that really resonate with people like happen to output in a way that is really really compelling. So that's like the base case of RLHF as like style transfer and still being important to just kind of get this flow of the model right. And then there's other stuff that OpenAI makes a lot of funny noise about. Well, they don't make noise about it, but the leaks do, which is like all this Q star stuff and adding extra search at the fine tuning phase, which is various ways of just getting very new types of data. And it's what I was talking about at the beginning with this different loss function. It's like the way to exploit the fact that we're no longer doing autoregressive loss and see how far that lets us create different types of language models or other types of ML models, which I need to make a talk on this, which is like the like why people are bullish on RLHF, which I haven't done it. I think I need to learn a lot about it though, because it's like hard to make it more than like 2 slides. It's like, what does it actually mean that you're doing these policy gradient updates rather than this autoregressive loss?
It's wild to hear someone who is so expert in RLHF describe it like that.
Someone at OpenAI gave a talk that said this. I think it would have been like, I don't remember. There's like the NYU professor that's also at, it's like maybe his last name. It's like I don't know how to say it, but I could find it later. But he had this slide in his talk, which is like the language modeling 101, and like that was how he presented RLHF, and I was like, that's a good way to do it.
Nice, yeah. Beyond all of your professional work, which we've discussed so far, about a year ago, you wrote a newsletter, an article in your newsletter called "Behind the Curtain: What It Feels Like to Work in AI Right Now: Fear, FOMO, and the Scientific Exodus Driven by ChatGPT." I totally feel this too. Like it seemed like, it seems so hard to be able to find like terra firma, something constant that you can just like be like, okay, investing in understanding that is going to be great for my career for years to come. It seems like everything's moving so quickly. That yeah, it is scary. So yeah, so I don't know if you want to talk more about that article, and
People have
basically,
settled down a bit. I think this was a transition period to where we're at now. Sorry to cut you off a little bit, but it's like we're the pace is just so high. But I think there are fundamentals that you still like learning how to use language models is good. Like it's almost like when I started my PhD, it's like learning anything to do with deep learning and PyTorch and all these things is good. And I think like Hugging Face Transformers is a place to start with things. It's good to like play with different models. I think it's like an in vogue thing in the industry to be like, oh, their code isn't very good. It's not very optimized. But like if you're a first year grad student, it's like easy to play with a ton of models. And that's what their business is about, is like enabling people to use this. And like those things pay off. Like I play with stupid AI things. Like I transform my newsletter into like AI generated voice stuff, and just getting used to working with all of these things is now the like fundamental skill that will pay off in 10 to 20 years, because there still probably will be something like an OpenAI API. It'll just be much better. And that's like Carpethy's take that language models are like a new computer processor type of thing. They're just a fundamental computing unit worth getting used to. That is worth getting used to. And this article was when we were all kind of readjusting to this. Like, I think it's actually a bit better now. I think there's still a lot of people complaining. I think that was like yesterday, Jan LeCun tweeted this thing, which is like, if you want to have true impact in AI, don't work on language models. And I just feel like there's so much gatekeeping against telling people, like, just go be excited and try things, which was one of like I tweeted, I like quote tweeted to say the opposite, which like you can have a nice life and work in language models. So it definitely brings out the like haters for some reason. They're like, this is a bad take. It's like, why? Like, you just have to go play with things. And if you're building things, it's much less important what the noise is because you're actually doing things rather than like sitting back and getting bombarded with these random release this, release that, which is obviously cool, but most of them don't matter. And it's just like good to get grounded in actually doing stuff. I don't know if that answers your question, but I don't expect this to change. This is fundamentally driven by the VC cycle where it's until these companies that get really ridiculous funding rounds start to die, like we're going to be in this cycle where there are so many releases all the time because that's what all these startups need to do to get customer inbound, to get PR. It's like until these companies start dying, it's going to be the same. And then after that is this aggregation phase and collapse. But we don't know if that's going to be a year or 5 years from now.
And I like your point in there that LLMs, they make things, they provide so many different kinds of applications that we can be building now that we couldn't before. And another great advantage of them is that it also just it makes my workflows a lot easier, whether it's an inline code assistant or something like Claude, which I use for questions that I just have about the world all the time. So yeah, uh, it is exciting, but yeah, it can be scary at times. And so
It's worth reading that article to understand what the zeitgeist was like if you were a student. Like that was really built up just talking from everyone at Hugging Face. That's all just was like freaking out collectively, and I was just like, I'm just gonna. It's like fired up one afternoon. I'm just gonna go put all of this on a page, and it's. I think it's a good capture of the moment when something kind of goes viral like that. I don't think I could recreate it because we're in much more of a steady state now. Like we're no longer in this super high entropy state. It's noisy, but most people are used to it.
yeah, makes sense. So in terms of being able to have a better work-life balance, so I mean, to not be fearful of things, to just allow mental health to always come first, which is something you've written on your website. You've managed to integrate your passion for cooking, fitness, and health into your daily routine. How does this influence your approach to work? And do you think this is helpful for achieving work-life balance?
Yeah, I think the realistic take on what I do is like a kind of contrived, partially what I'm like still self-identify as because it helps me be healthy. Because I have a long history of endurance sports from college and growing up, and I still do some of this stuff. And it's like a basic rule tree of like, do I sleep well? Yes or no. And if the answer is no, it's like I feel during training, and it's like I just wanted to feel good at these things, and I just lean into this enough to make it obvious that I'll like not work late. It's like I don't need to. But obviously like things come up, but I don't think I've ever done an all-nighter at grad school or anything. Like it's and this is how it works for me is like training and trail running and getting outside. And it's mostly finding what works for you. And I do think it's worthwhile. That was a part of why I want to be in person. It's like if you're really I think a lot of people in CS and related fields are so good at optimizing and organizing their life, which is like being remote is so convenient that I can like overdo this, which is like I'm like, oh well, it's 5 p.m. I gotta go do my workout now. Where it's like if you have to walk 20 minutes into the office, it's just like a bit more structure to like take back control of your life, which is why that's like, gonna help me a lot. And you just need to have things in your life that make that the case to just have like have some sort of things that you don't control and things outside of work. It's hard though. I think it's still coming out of COVID in that regards. I mean, you do remote interviews a lot of the times. Like I don't know how to balance that. Like I've thought about interviews for my blog and I'm considering whether or not I only do them in person, which is like go to a conference and I bring a microphone and I see if I can get somebody interesting, which obviously reduces my throughput, but it's just trying to make these rules in my life that reinforce doing things that are actually in the real world. So I think about it a lot, and I don't think there are perfect answers.
Yeah, it's crazy for me personally. The pandemic was, I mean, it still continues to have a negative impact on me in a lot of the ways that you're describing because I used to have this routine of going to the office and being around coworkers all day and that like laughing, like I really enjoyed being at work. And now I mostly work from a home office. And I've even, you talked about over optimizing there. I picked an apartment that has a CrossFit gym across the street, but now I kind of regret that decision because I'm like, I can spend my whole day in my apartment, and like the only thing that I go to do on a typical day is go down to the gym that's across the street. So I'm not like, yeah, I've over optimized, and yeah, working some things out there myself. Anyway, um, so thank you so much for this great, rich conversation on robotics research, RLHF in particular. Before I let my guests go, I always ask for a book recommendation. I don't know if you happen to have one for us.
I'm reading some things that I like right now. So I'm finishing the Three Body Problems series. So the second and third books, I don't think have the peak level of the first book. The first book has two moments in it that I won't spoil that I think are some of the best sci-fi moments in any literature. So Three Body Problem is really worth reading for these kind of key moments. And then it's just like great, hilarious sci-fi, which is good for getting out of these things that we talk about. And a timely one for people in AI is I've been reading Going Infinite by Michael Lewis on the Sam Bankman-Fried FTX stuff. And reading this, especially if you read some of the like this behind the curtain article, it's like, we're going to get this about AI. I think there's memes on Twitter where people are saying that the title is going to be not consistently candid and it's going to be about Sam Altman. But I think Sam Altman has achieved real things. Like his success is not going away. He might just have personal things that make it harder. But there are going to be other books where it's like these AI companies like come and go in the most dramatic fashion. And just reading that to make sure that you have a good sniff test of total bull is probably good. I could probably dig up a more evergreen, non-classic techie book recommendation, but those are the things that I'm reading and I'm enjoying them, and that's normally good enough.
Yeah, it's great. Great recommendations. Three Body Problem has come up quite a few times as a favorite book on this show. But Going Infinite is new, and that sounds great. I love Michael Lewis. I've loved him for years.
Yeah, it got weird reviews, so I took a second to not get into it, but it reads really well, like all of his books. So I'm like, this is just it obviously has bias. It's not perfect, but it's solid.
He's unreal at making what could be quite dense topics like Kahneman and Tversky into a page turner.
Yeah.
Awesome. All right. So in terms of following you after this episode, we've already talked about your newsletter, interconnects.ai. We've talked about your podcast, The Retort. How else should people follow you other than those?
Those are really the main things. I'm at Nathan Lambert on most platforms, but somewhat begrudgingly, I only really use Twitter for random thoughts. I'll promote my work on other channels, but the only other additional point of information is going to be Twitter. But I try to make the good things in the blog just for my own sake, but it's good to try to condense them down to be less noise. It's always easy to tweet more, but you don't necessarily gain more from tweeting in terms of actually learning anything.
All right, Nathan, thank you so much for being on the show today. Such an awesome guest. And yeah, we really appreciate you taking the time, and hopefully we'll catch up with you again in a few years.
Yeah, thanks for having me. This is good questions.
What an eye-opening episode. In it, Nathan filled us in on how DDPO allows for intent alignment in smaller models, allowing Zephyr 7B to surpass Llama 2 70B on some benchmarks. He also talked about how dexterity, ambi, and covariant are the big players in robotics, but that today's humanoid robots have too much force to be around in many everyday situations. He talked about how RLHF can scale up fine-tuning at a lower cost and help resolve whether disagreement among human labelers is a signal or a bug. And he talked about how RLHF can have a positive social impact by fixing the pre-training biases that crop up due to pre-training LLMs on data sources like Reddit. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Nathan's social media profiles, as well as my own, at superdatascience.com/791. If you'd like to engage with me in person, as opposed to just through social media, next week I will be at the Collision Conference in Toronto. It's a 4-day conference On the Thursday of the conference, I'll be hosting an afternoon of sessions on the content creator stage. Beyond the sessions that I host, other amazing speakers you can check out include the godfather of AI himself, Professor Jeffrey Hinton. We'll also have Aravind Srinivas, the CEO of Perplexity, Aidan Gomez, CEO of Cohere, and the tennis legend, Maria Sharapova. Thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another fantastic episode for us today, for enabling that super team to create this free podcast for you. I'm so grateful to have the sponsors that we have. You can support this show by checking out our sponsors' links, which are in the show notes. It's a huge help to us if you do that. And if you yourself are interested in sponsoring an episode, you can get the details on how by making your way to johnkrohn.com/podcast. Otherwise, share this episode with people who would like it, review the episode on whatever platform you listen to it on, subscribe if you aren't already a subscriber, but most importantly, just keep on tuning in. So grateful to have you listening, and I hope I can continue to make episodes you love for years and years to come. Till next time, keep on rocking it out there, and I'm looking forward to enjoying another round of Super Data Science Podcast with you very soon.